Okay, a couple of more examples. Still forces at an angle, but I could make your life more difficult. And I can make your life more difficult by either not giving you the force. Oops, I guess this is number 10, not 11. By either not giving you the force or not giving you the mass. So let's start off by me not giving you the force. So let's say this is a toboggan, and it has a mass of 50 kilograms. And I'm pulling upward with some force, and I don't know what it is, but I know I'm pulling upward at an angle of 53.13 degrees. So this is my Fx, and this is my Fy. Okay, there's still gravity, of course, acting down. There's still a normal force acting up. And there's friction acting backward. Okay, and so the question would go something like a toboggan, a mass 50 kilograms, is being pulled by a force acting upward at an angle of 53.13 degrees. If the coefficient of friction is 0.2, and the toboggan accelerates at a rate, I think I want to make it 0.3. Coefficient of friction is 0.3, and the toboggan accelerates at a rate of 1.5 meters per second squared. What must be the force that you're pulling with? Okay, so you can go and get your components in the X and Y, at least get a representation of them. So in the X direction, it's the adjacent side, so it's going to be cosine. So cos theta is equal to Fx over F. So Fx is equal to F cos theta. But you cannot find it because you don't know the F. So just stop here. Don't even bother to fill in the theta. You know it's 53.13, but why write it down? That's 4 more digits that you have to put there that you can't use right now. So then get the expression for the y. So sine theta will equal Fy over F. Rearrange for Fy. So Fy will equal F sine theta. And again, you can't find it because we don't know the F. But that's all right. We're going to carry it through. So we're going to go to the sum of the forces in the y direction. And that's equal to MAY. So remember, that's really right. We get our x and y components for F, and now we go to the y direction. And there are 3 forces in the y direction. There's Fn, Fg, and Fy. And this toboggan is not moving in the y direction, so they're going to be equal to 0. Fn is up, so it's positive. Fg is down, so it's negative. And Fy is up, it's positive. And we're still trying to find an expression for Fn. So take the other 2 terms over. So it'll be Fg minus Fy. And then you could write it as Fg is mg. And up here we found out that Fy was F sine theta. Okay? Can't get a number for this, so don't bother filling in 50 kilograms and 9.81 and 53.13 degrees. Just leave it as letters because you can't go any further. You can't get a number for it anyway. And so then we know friction is equal to mu Fn. So that means friction is equal to mu brackets mg plus F sine theta. And again, just leave it as is. And we're going to use it when we go to sum of the forces in the x direction. So sum of the forces in the x direction is equal to max, and we have Fx minus friction is equal to max. But Fx we know is really F cos theta minus, and friction is really all of this. It's really mu brackets mg plus F sine theta. And that's equal to max. So we're trying to solve for F. If there's an F in this first term, and there's an F stuck inside the bracket there. So the first step before you try to solve for F is you have to get rid of those brackets. So multiply through by the negative mu. And it'll become F cos theta minus mu mg, and then negative mu times F sine theta is going to be negative mu F sine theta is equal to max. Now keep your two terms with F on one side, take your mu mg over to the other side, so it'll be F cos theta minus mu F sine theta is equal to max plus mu mg. Did I mess up? This was going up, it's positive. Take it over, and it becomes negative. Negative, and then for some reason it morphed here to negative. I knew it was supposed to be a negative there. Negative here, and now when I multiply through, it's positive. I knew something was wrong. Whoops, and I lost my F. All right, now you're going to factor the F out here and on this side, so it'll be F brackets cos theta plus mu sine theta. And on this side, that will equal max plus mu mg. So just like that other question where we were solving for the mass, it wasn't angled, but it was the same idea. We pulled the m out here, we're going to pull the f out. And now to get the force all by itself, we're going to divide by the bracket. So it's going to be F, I'm just going to move it over here, max plus mu mg, and then divided by cos theta plus mu sine theta. And now that you have it all separated for F, now fill in your numbers. The m was 50 kilograms. The a was 1.5 meters per second squared. The mu was 0.3 times 50 kilograms times 9.81 meters per second squared, divided by cos of 53.13 plus 0.3 sine of 53.13. Now the next trick is, can you punch this in your calculator correctly? The top should be easy. The bottom, you need to put the whole bottom in brackets, okay, to punch it in correctly. You should get a top of 222.15 newtons, and on the bottom it should be 0.84. Might be another digit there, I'm not 100% sure. And when you divide, you should get F to be 264.464 newtons. Okay? So it's not a bad thing. It helps you start to carry your letters, and that in the end, as you get more used to it, it will get easier. All right, example 11 is similar, only this time I'm not going to give you the mass. I'll give you the force, but not the mass. Okay, so example 11. So you have a box, unknown mass. This time let's push downward with a force of, let's say, 400 newtons, angle of 36.87 degrees. This will be my Fx, this will be my Fy, my Fg, my Fn, and backward will be friction. In the question, you're told that the coefficient of friction, this time it really is 0.2, and the acceleration in the x direction 2 meters per second squared, and it wants to know what is the mass. When you do your components for your force, again, I would leave them just as letters, right? Even though you could actually find them here, I would leave it as F cos theta for my x and F sine theta for my y. I wouldn't fill my numbers in yet. I'd wait until I go to fill my numbers in at the end, because you don't have the mass, so you're not going to be able to get a value for Fn anyway. Right? So we go to sum of the forces in the y direction is equal to may, and it'll be Fn minus Fg minus Fy is equal to 0. So Fn will equal Fg plus Fy. So Fn will equal mg plus F sine theta. I'm going to run out of time here. And before you start the next video, why don't you see if you can finish this one? Okay, so it'll be FFR is equal to mu mg plus F sine theta. And then this is what you're going to sub into in the y or in the x direction. So sum of the forces in the x And so when we run out of time here in 2 seconds,